In this lecture, we will talk about constraints. There are many different types of constraints. We have point constraint, aim constraint, Orient constraint, scale, and parent constraint. Each of these things works in slightly different ways. Let's take a look at this example. I have a sphere here and a cube here. Let's take a look at both of their channel box. As you can see, there is no connections, meaning that there is no keyframes or there is no different colors for any of these attributes. You can check on both of them. So sphere, it's also empty. This is also empty. The order that we select is also very important. So the one that you select first is going to control the one that you select second. So I select the sphere first, press shift key and select the cube, and I will apply a point constraint. Now as you can see that the box actually disappeared and the box has got some blue color on all these translate attributes. Now to find out where the box is, let's go to our wireframe mode, and you can see that the box is actually sitting right in the center of the sphere. This is because what it actually does is it takes the translate values, that is translate x, y, and z, and puts the same exact value on this object. Meaning that if I move the sphere, let's say 1 unit, I'll give an exact value of 1 unit, and the box also moved the same 1 unit. And this connection basically tells us that whatever value we are going to give for this one, the same value will also be taken by the cube. So which essentially means wherever I move the sphere, the cube will follow it. Now as you can see, when I made the point constraint, the cube moved to the center of the sphere. Now what if I want to create the same point constraint, but I don't want this cube to change its position, I want it to maintain in the same place. Now what we can do is we can select the same order, okay, go to point constraints options and turn on maintain offset. So what it will do is it will just maintain this distance when the constraint is being initially created, and then it will keep on moving it wherever this object goes. Let's go ahead and hit add. Okay, now we have a constraint. As you can see, it becomes pink in color, which means that there is some kind of connection between these two. And you will also notice that these translate attributes have become blue in color. And now when I move this object, it will also move wherever this sphere goes, but still maintaining the distance that we have initially. Let me undo that. Okay, no more constraint is there. Now you can also remove a constraint by going to edit, delete by type, constraints. Let's go ahead and select these two things in the same order as we did before. This time I will choose Orient constraint. Now what Orient constraint will do is Orient constraint creates the similar type of constraint but to the rotation. So that means wherever I move this, it is not going to make any change, but if I rotate this object, the box will also rotate. So whatever rotation value I'm giving here, the same rotation value will also be given to the box. But at the same time, wherever I'm moving it, it is not going to affect, but only rotation will get affected. Let's go ahead and make all these values 0. I'll remove the constraint by selecting these two, going to edit, delete by type, constraints. So as you can see, the constraint is being removed. Now combining this point and Orient constraint, we can also choose parent constraint. So what that will do is it will create connections in both translate and rotate. Let's hit parent. As you can see, wherever I move this object, that object is also going to move along, and when I rotate this also, it is going to rotate. Now the only difference, because this is a parent, it is not rotating from the center of that object, it is rotating based on the center of this parent object. So I'll just reset everything. I will delete the constraint. Now let's see how we can see the difference between parenting and parent constraint. I'll undo a couple of steps. I'm going to remove this constraint. We have a cube and a sphere. I will make a duplicate of them, move them out, and for this first one I'm going to apply a constraint, and for the second one I'm going to apply parent. I'll select this sphere first, that is the parent first, and then shift select the child to apply a parent constraint. And you can notice how the hierarchy remains the same. This time I will choose child first and then the parent, and I will apply a parent, not constraint, just parent. You can also press the P key, and this time you will notice that the sphere stays up and the cube goes inside the sphere. But in this case we can see that they both stay in the same hierarchy, but there is a constraint that is attached to it. So this is the major difference between parent and parent constraint. We have scale constraint, which basically does what it says. So I'll create a couple of objects. Let's say I create a torus. Fine. Now let's look at the other constraints. We have scale constraint, where you can select the first object, that is the parent and the child, and apply a scale constraint. So what it does is it simply takes the same value of scale and puts it here. So if I make it bigger, the torus also becomes bigger. If I make it smaller, the torus also becomes smaller. But this will not affect the rotation or translation. So no matter where I move it, it is not going to be affected. No matter if I rotate it, it's not going to be affected, but only the scale will be affected. And last but not least, we have aim constraint. We've already learned aim constraint with the rigging of I. Anyway, I'll do it again. So I'll create a cone and a cube. I'm going to move the cube away, okay, and I'll check out the local rotation axis. And to make it more interesting, I'm going to modify this a little bit. Okay, now we have to look at the local rotation axis for this object. We can go to display, transform display, and local rotation axis. So that will show us the local rotation axis, and you can see that y-axis is looking up. So y-axis should become the aim vector, so that the aim will be moving, looking at this cube. So again, I will select the parent first. Let's make sure that we're in object mode. Select the parent first, shift select the child, and we'll go to constraint, aim constraint. Let's go to options, and let's reset everything just to make sure that we start perfectly. And aim vector is supposed to be y, so we'll make this x to be 0, y to be 1, and when y becomes the aim vector, something else has to be the up vector, so it can be either z-axis or x-axis. So this time I'll make it x-axis and keep the others to be 0, and I'll hit constraint axis to all and hit add. So now you can see that wherever the cube moves, the arrow will point straight at it. Okay, so this is basically controlling the rotation of an object based on the position of an object. So this concludes this tutorial on constraints.